Hello again. This is Mr. Fletter. Some of you asked that if I would make a video on our phases of matter liquid reinforcement assignment that you did the other day, so I thought I'd do that real quick. We're not going to go through the entire thing, but I'll kind of hit the most important parts. So the task was to figure out which liquid would be on the bottom. If they were all spilled together, liquids will kind of arrange themselves according to their density. So you needed to find the density. So in order to do that, we would use the formula density equals mass divided by volume. And the thing that was important to remember, they give you the volume and the mass, and it has to be in the correct unit. So we need it to be in grams for mass and milliliters for volume. And so the first one is in the correct unit that we need in order to find out the density of the green liquid. So in order to do that, I would use the formula density equals mass divided by volume. Density equals 36,000 divided by 48,000. And if I did that calculation, I would get density equals 0.75. Okay? So that's where you would put it down here. The density is 0.75 grams per milliliter. And you would then go ahead and do that for the rest of the liquids. One thing to keep in mind, there's a problem with this. This is not in milliliters. It needs to be in milliliters. This one's okay, because it's in grams. This one is not okay. We need that to be in milliliters. And so if you look back up here at our hint, 1 liter is equal to 1,000 milliliters. So if you are given something in liters, you just simply multiply that times 1,000 and you would change it to milliliters. So that would be 144,000 milliliters, and you already have it in grams. So to calculate that, you would do density equals mass, 129,000 grams, divided by 144,000 milliliters. And if I did that on my calculator, 129,000 divided by, I would get a density of 0.895, so I would round that up to 0.9. So if we're just comparing the first two, the liquid that would be underneath the other would be the one that is denser. So since blue has a higher density than green, 0.9 is larger than 0.75, this one, the blue liquid, would be on the bottom. If you continued to do that for the red, the black, you would find their densities, and if you did that correctly, looking at the red liquid, we have this in milliliters, that's good. This is in kilograms, that's not good. We need to change that to grams, multiplying that times 1,000. So you would do 113,200 divided by 96,000, and you would get a density of 1.18 rounded to the nearest hundredth grams per milliliter. The black liquid is in liters and in kilograms, so we need to multiply both of those numbers by 1,000 in order to change them into milliliters and grams. So we would have 120,000 milliliters and 96,000 grams. And again, you would take the mass divided by the volume. So that would be 96,000 divided by 120,000, and you would get a density of 0.8 grams per milliliter. All right, so then you just simply compare the densities. The liquid with the highest density is the red, so that would be on the bottom. The next highest would be the blue. The third would be the black. And on top you would have the green liquids. Remember, dense things sink. So if something is denser than something, if you put them together, the one that has higher density is going to go underneath it. Okay. So then you would look at your tank down here. color that the correct color. Your red would be on the bottom. And then how would you remove it? You would simply open the tap, and the densest liquid, which is red, would come out of the tap. On the back side of the page, you needed to find the volume, just a little math review, finding the volume of regular shaped objects and irregular shaped objects. So if you have an object that you can measure the length, the width, and the height, you can simply multiply those three dimensions together to find the volume. So in this one, you have a 2 by 2 by 5. So I would do volume equals length times width times height. Volume equals 5 times 2 times 2, and I would get a volume of 20 centimeters cubed, which is also, just to remember, a centimeter cubed is equal to a milliliter. This one's pretty easy. It's a 6 by 6 by 6. Volume equals 6 times 6 times 6. And 6 times 6 times 6 is 216. And I would label that meters cubed, because that is the unit that we're talking about. And then to find the volume of an irregular shaped object, you have to use a graduated cylinder and use the displacement method. So they filled the graduated cylinder to a certain point, which it looks like it's 3.4, because this is going up by 2's, each little hash mark, 3.4, and it rose, when they put this little guy in, it rose up to 5. So if you take 5 and you subtract 3.4, you get the amount that it rose, or the amount that the irregular shaped object displaced the water, would be 1.6, and that is in milliliters. Okay, so hopefully this was a helpful review of finding volume and the liquid reinforcement of finding densities. Have a great day.